Hey everyone, so at this point we have learned how to solve systems of equations or simultaneous equations using our three main methods, the graphing method, substitution method, and elimination method. So now we are going to talk about real life problems. So what if we have a situation where we need a system of equations? How do we even know that it's a system of equations problem? And then how do we come up with our own equations to solve, right? Because up until this point, we've been giving you equations. We don't know what the x and y represent, but we know how to solve them. So we're putting it all together right now. Let's start off with our basic steps. If you were to be given a word problem, how would you tackle it? So our first step is to identify two unknowns in the problem. So we need to figure out what are the two things that we're trying to figure out the value for. And then we need to label them with variables. Now you can use whatever variables you want depending on the situation. Most people use X and Y, but sometimes if we're talking about, like, let's say apples and pears or something, then we would use A to represent apples, P to represent pears in that situation, because it's much easier and intuitive to, once you figure out A, to know that that's the number of apples, rather than trying to figure out, like, wait, does X represent the apples or does Y? So sometimes people like to use variables that correspond to whatever the unknown is. So you first have to figure out, after reading your problem, what am I even trying to figure out, and then label them with variables. Then the tricky part is you have to create two or more equations, each equation representing a different situation that's being described in the problem. And we'll talk more about that. Then you solve the system using any method you want, because you can choose depending on the situation or what your equations look like. And lastly, of course, check your answers once you figure out the answer. So let's take a look at this problem here. Example 14. A two-digit number is equal to 4 times the sum of its digits. If the digits of the number are reversed, the new number formed is 27 more than the original number. Find the original number. Okay, so we're talking about a mystery two-digit number. We have no idea what's in the tens place and what's in the ones place. That's our unknown right here, okay? So let's say, well, we could say T represents tens place digit, and we could say O represents ones place, but then O looks a lot like a 0. So we could just keep it as X and Y, okay? So X will represent the tens digit, and Y would represent the ones digit. Okay, so we figured out our unknowns. We have no idea what those two digits are in that number, and we're kind of labeling so that later on when we figure out X, will know it belongs in the tens place and Y belongs in the ones place. All right, step 1 done. Now let's read the problem. We have to come up with two different equations to represent each situation that's being presented to us. So this two-digit number is equal to 4 times the sum of its digits. Okay, so it's equal to, I'm going to not mess with the two-digit number yet because it's two digits. One's in the tens place, one's in the ones place. Let me deal with that later. But the two-digit number is equal to 4 times, multiplication, the sum of its digits. Well, the sum would be to add those digits, sum of X plus Y. I'm putting that in parentheses because this entire sum has to be multiplied by 4. So if I don't have parentheses, only the X would be multiplied by 4. So this is a situation where distribution is needed. I need to add X and Y first and then multiply by 4. All right, going back to the two-digit number part. A two-digit number is equal to 4 times the sum of its digits. So the two-digit number, I can't just put X and Y, right? This two-digit number has a value. My X is in the tens place. So whatever that digit is, like let's say if it was 4, it doesn't just represent 4, right? It represents 40 because it's in the tens place. So I'm going to take my x value and I'm going to multiply it by 10 so that I know at the end if I get 4, it's really a 40. And then it's being added to a ones digit. Ones digit is just itself, so I can add it to y. Okay, so at the end, let's say it was 43, it would be 4 times 10, which is 40, plus that 3 to equal 43. So that's the tricky part about this problem. So the two-digit number, which is taking into consideration its place value, is equal to 4 times the sum of its digits. Okay, so we made one equation for the first situation. The first sentence was talking about this particular situation, this particular puzzle. Let's move on to the second sentence, and whatever the second sentence is talking about, we're going to make into our second equation. So they are saying if the digits of the numbers are reversed, the new number formed is 27 more than the original number. Okay, so if the digits are reversed, that means now the y is in the tens place, and the x is in the ones place, so x would just be by itself. It doesn't need to multiply by anything. And remember, those two are added together to create that digit. The new number, which is this, tells me equal 27 more than the original number. Now remember, the original number was when x was in the tens place and y was in the ones place. You could put parentheses around this, but it's just addition, so it doesn't really matter. We really care about parentheses when there's a multiplication because that means distribution. If I were to put parentheses here, it just doesn't change anything because it doesn't change anything with order of operations. It doesn't have distribution. It doesn't matter. So you can put it there or not. Okay, we have our two equations based on the two situations that we read. Now we're going on to step 3, which is where we can just solve it normally using whatever method we want. Okay, before I do that though, I'm probably going to want to just simplify these two equations because there's just a lot of mess going on. So maybe I want to first distribute this. So the first equation would become 10x plus y equals 4x plus 4y, okay? And then, let's see, the second equation can stay the same, but you know what? Let's change it so that maybe we're putting it into that elimination method format, right? So that all our x's and y's are on one side and our constants are on the other. So let's move stuff around. So let's subtract 4x and let's subtract 4y on both sides. Okay, we're going to do the same thing on both sides. I'm just combining some steps here. This will cancel. On the right-hand side, it'll just be equal to 0 because there's nothing there. There's no numbers in this problem. So 10x minus 4x is 6x. 1y minus 4y is minus or negative 3y. So this is my first equation now, my new first equation. Let's change up the second equation. Let's subtract some stuff. Let me use a different color so that we don't get our work mixed up. So again, I'm going to move all my stuff to one side so that later on, hopefully I can use my elimination method. So let's subtract, let's see, 10x here and subtract y here, subtract 10x, okay? So these cancel, I'm left with 27, and then I have 10y minus 1y is 9y, and I have a 1x minus 10x is negative 9x. Oh, let me switch these around so later on I can stack them. Negative 9x plus 9y, because this is a positive, equals 27. Okay, let me write that negative clearly. So this is my first equation and my second equation now. And then I can use the elimination method. So let's do that. I might be running out of space, so let me try and write this a little smaller. Let me use this magenta. And let me just, Well, in order to stack them later on, none of them really match. But I have a negative 3y here and a positive 9y, so I can go ahead and multiply this equation by 3. So I end up with 18x minus 9y equals 0, because anything times 0 is 0. Let me stack them together over here. Sorry if this is messy, I'm just running out of space. Okay, so I'm doing my elimination method right here. And then these cancel, I want that. So then 18 minus 9 is positive 9x equals, these get added together, 27, divide both sides by 9. So I get x equals 3. Awesome. If x equals 3, let me see if I can plug it into something so that I don't have to do that much work. Well, I can plug it into, how about, yeah, let's plug it into this 6x minus 3y equals 0. How about that? I have so many equations because I've like just changed everything so many times. Let's add 3y to both sides. So I end up with 6x equals 3y. Well, x equals 3, so 6 times 3 equals 18. So 18 equals 3 times y. What would y have to be? Well, if I divide by 3, y would equal to 6. Okay, so I have x equal to 3, y equals to 6. So my number is 36. Let's reread the problem, see if it works. Okay, so I have, I'm going to use my calculator here, a 2-digit number, 36, is equal to 4 times the sum of its digits. Okay, the sum of its digits, adding them together would be 9 times 4. Does 9 times 4 equal 36? Yes. So it's equal to 4 times the sum of its number. The first one checks out. If the digits of the number are reversed, so it becomes 63, the new number is 27 more than the original number. So is 63 27 more than 36? Yes, it is. So we have the correct answer. Okay? Again, I apologize for the mess. I just had to fit everything on one screen. I'll see if I can write a little smaller on the next problem. Okay, so this next problem, example 15. The total price of 3 burgers and 2 pizzas is $27. The total price of 4 burgers and 3 pizzas is $38. Find the price of a burger. Go ahead and pause the video and try this on your own first. All right, so my first step, remember, is to figure out my 2 unknowns. I need to figure out the price of a burger. That's the question. And obviously a pizza, because I don't know that price either. So I'm going to name B as the price of a burger, one burger, and I'll name P the price of a pizza. Okay? Pretty self-explanatory. Not using X and Y because there's no point in that. That'll just confuse us. It would suck at the end if I end up getting the right answer, but I switched them, right? Because I couldn't get my X and Y in order. Okay, so step 1 done. Let me read the first sentence. The total price of 3 burgers and 2 pizzas is $27. Okay, well, I don't know the price of a burger, but if I'm buying 3 burgers, I'm going to take however the price is for however much the price is for a burger, and I'm going to multiply by 3 because I'm buying 3 of them. And it's the total price, so I'm going to add it to the 2 pizzas, 2 times whatever the price of the pizza is, added to 3 times whatever the price of the burger is going to equal to $27. There we go. That's the first situation. Oh, I said I was going to write smaller, but I didn't. The second equation, the total price of 4 burgers, 4 times the price of 1 burger, and 3 pizzas, 3 times the price of 1 pizza, is equal to 38. So there we go. We finished step 2. We wrote one sentence for each situation. Find the price of a burger. So I just need to know the price of B. All right, I like this one because it's already stacked together and I can clearly use elimination very easily. So let's go ahead and try that then. Well, I can get the b's to match for their coefficients, or I get the p's to match their coefficient. Let's go with the p's because they're smaller numbers, so maybe we won't have to do as much math. And they're all positive, so one of them's gonna have to be negative. Gonna have to unfortunately multiply both of them. Let's get them both to 6. Let's multiply the top one by -3, and let's multiply the bottom one by a +2. All right, let's rewrite them down here. So -3 times +3 is -9b, minus, because it's -3 times 2, minus 6p equals 27 times -3. 27 times 3 is 81. So that's going to be a -81 because one's positive, one's negative. And then let's do our second one. Just multiply by 2. So we have 8b plus 6p equals 38 times 2 is 76. Yes. Now I can stack them together and add them together. So these cancel. Perfect. I wanted to figure out the price of a burger anyways, so I get left over with the B. I probably should have been strategic. I just ended up choosing the easier one, but I should have been strategic. It ended up working out. I should have thought to myself, I need to find B, so let's get rid of P. Ended up working out, but just note to yourself. -9 plus 8 is -1B. And then we have -81 and 76. So that answer is going to be negative of whatever the difference is. 76 is just 5 less than 81, so it's -5. This is a negative b, so if I want to find a positive b, I just switch the signs because this will be a +5. And really the reason why you just switch the signs is because you can pretend like you're dividing both sides by a -1, and that really just switches the signs. Negative becomes positive, positive becomes negative, okay? So my B is 5. I can check my answer by plugging it in. 3 times 5 plus 2 times P equals 27. So 3 times 5 is 15. So we're going to subtract 15 both sides. And then 2p would equal to 12. So one pizza would be equal to half of that, which is 6. Okay, so let's check our work then. So if a burger is $5 and a pizza is $6, let's check it. I'm just writing over there so I can look at my calculator at the same time. The price of 3 burgers, 3 times 5 is 15, plus 2 pizzas, 2 times 6 is 12, is 27. Yes, that should work because we just used that equation. The total of 4 burgers, 4 times 5 is 20, plus 3 pizzas, 3 times 6 is 18, is $38. Whew, good. I hate doing the whole entire thing and then you end up getting it wrong, right? Find the price of a burger. So we are pretty sure that it's $5 per burger.